You're setting up for a big recording session. You've got 24 tracks, you're recording at 24-bit, 96 kHz. You think you have enough hard drive space. Are you sure? As an audio professional, the last thing you want is for a hard drive to fill up during a once-in-a-lifetime performance. Guessing is a risk, and stopping the session is not an option. So how do you plan for it? Why do these high-quality files take up so much space? What's the real difference between a WAV, a FLAC, and an MP3? And is there a way to calculate exactly how much space you need before you press record? In this video, we're gonna break down the simple math of audio file sizes. We'll see why one 3-minute file can be 50 megabytes while another is only 5. We'll explore the difference between uncompressed, lossless, and lossy audio, and figure out when to use each one. In our last video, we covered how analog sound is converted into digital ones and zeros using pulse code modulation. This is the raw, uncompressed data. The file formats you know best, like WAV and AIFF, are basically containers for this PCM data. They contain a perfect bit-for-bit representation of the digital audio with no quality loss. This is what we call uncompressed lossless audio, but this quality comes with massive file sizes. So, how do we figure out exactly how much space we need? For uncompressed files, the calculation is based on the number of channels, sample rate, bit depth, and length. Let's calculate a 1-minute stereo track with sample rate at 48 kHz and bit depth at 24-bit. That's 2 channels times 48,000 Hz times 24 bits times 60 seconds, giving us 138,240,000 bits. Now to make sense of that number, we convert it. There are 8 bits in every byte, so divide by 8 to get bytes. Divide by 1024 to get kilobytes. Divide by 1024 again to get megabytes. That's 16.48 megabytes for 1 minute of stereo audio. Let's take another quick example. 5.1 surround audio, that's 6 channels at 48 kHz, 24-bit for 5 minutes. After we apply the conversions, and that's over 247 megabytes for just 5 minutes of surround audio. Now, let's take a big recording session. 48 tracks at 96 Hz and 32-bit for the high-resolution audio. For just 1 second of recording, the math is 48 channels times 96,000 times 32 bits, which is over 147 million bits per second. After converting, that's 17.58 megabytes used every single second. A 30-minute recording would be about 31 gigabytes. Now, imagine recording a 2-hour live concert with that same setup. You'd be looking at over 123 gigabytes for that one performance. And that is why you plan ahead. But what if we could make that file smaller without losing a single bit of quality? This is called lossless compression. Think of it like a zip file. It packs data more efficiently to save space. When you unzip it for playback, you get the exact original file back. Nothing is lost. The most common lossless audio formats are FLAC, Free Lossless Audio Codec, and ALAC, Apple Lossless Audio Codec. They can make files about 40 to 60% smaller than a WAV with zero quality loss. It's perfect for archiving your projects or for high-fidelity listening. But for distribution, even FLAC files are often too big. That's where lossy compression comes in. This is what formats like MP3 and AAC are. The name Lossy says it all. To make files dramatically smaller, they permanently throw away data. First, the encoder chops the audio into tiny frames and uses a Fourier transform to break that complex wave into individual frequencies. Then, it applies a science called psychoacoustics. Think of it this way. In a busy environment, if a loud car horn and a quiet bird chirp happen at the exact same time, your brain will only hear the car horn. The bird sound is masked. The encoder finds these frequencies and even rounds off the ones you can hear to save space and just deletes the rest. The result is a huge reduction in file size, but the trade-off is that the quality is reduced, and you can never get that lost data back. Because lossy files throw data away, their file size isn't based on sample rate and bit depth, it's based on their bit rate. Bit rate is that kbps number you see, like 128 or 320, and it defines how much data is allowed per second. Let's try a 1-hour podcast at 128 kilobits per second. Now, notice that K, it stands for kilobits. We could just go from there, but for the sake of clarity and to use the same conversion steps we use for the WAV file, let's convert it down to bits first. 128 kilobits per second is 128,000 bits per second, and in 1 hour, 3,600 seconds. 128,000 times 3,600 gives us 460,800,000 bits. We use the same conversions as before, and it comes out to just 54.93 megabytes. That's incredibly efficient for a whole hour of audio and a tiny fraction of the size of its uncompressed original. So, which audio format should you use? It's actually very simple and depends on the job. For recording, mixing, and mastering, always use uncompressed lossless. You need every single bit of data for the highest quality and best editing flexibility. For archiving your final masters, if you have enough space, leave files as WAV. But if you need to save some space, use compressed lossless, FLAC. It saves space on your backup drive without sacrificing any quality. For distribution and listening, use whatever works for you. Many streaming platforms offer lossless audio. If you have the storage space, unlimited data, and a high-end sound system to actually hear the difference, go for lossless. But for the gym, the car, or just saving data on your phone, high-quality lossy formats are often more practical and still sound great. We've done a bit of math today, but obviously you don't want to be doing this 5 minutes before the band arrives. You just want to be ready. To help you prep like a pro, I've created a free recording session plan that you can download right now. It helps map out your input list, your microphones, placement, and it includes a storage planning section so you can figure out exactly how many gigabytes you need before you even open your DAW. It's completely free, and the link is in the description below. Keep in mind, there's even more to this topic, like variable bitrate, joint stereo, and more file formats we didn't mention. If you want to see all the formulas in a handy file size calculator, check out the full blog post linked in the description below. And if you learned something, please click subscribe and like the video. Thanks for watching.